This is a once in a year type thing. I get to critique the Nobel Prize in Physics in 2019, and it's really convenient how both the prizes are, it's split in two parts to three people. So two people share one half, and one person shares the other half of the prize. But it's very rare that I get to do this because it both applies to exactly what I've been talking about over the last 8 years. New perspectives on our place in the universe. This is the press release, October 8th, 2019. This year's Nobel Prize in Physics rewards new understanding of the universe's structure and history, and the first discovery of a planet orbiting a solar-type star outside of our solar system. I'll read this whole thing out to you. I like reading to you guys. It's fun for me. James Peebles' insights into physical cosmology have enriched the entire field of research and laid a foundation for the transformation of cosmology over the last 50 years from speculation to science. His theoretical framework, developed since the mid-1960s, is the basis of our contemporary ideas about the universe. The Big Bang model describes the universe from its very first moments, almost 14 billion years ago, when it was extremely hot and dense. Since then, the universe has been expanding, becoming larger and colder. Barely 400,000 years after the Big Bang, the universe became transparent and light rays were able to travel through space. Even today, this ancient radiation is all around us, and coded into it, many of the universe's secrets are hiding. Using his theoretical tools and calculations, James Peebles was able to interpret these traces from the infancy of the universe and discover new physical processes. The results showed us a universe in which just 5% of its content is known, the matter which constitutes stars, planets, trees, and us. The rest, 95%, is unknown, dark matter and dark energy. This is a mystery and a challenge to modern physics. That's the first half. In October 1995, Michael Mayer and Dieter Kalos announced the first discovery of a planet outside of our solar system, an exoplanet orbiting a solar-type star in our home galaxy, the Milky Way. At the Haute-Provence Observatory in southern France, using custom-made instruments, they were able to see planet 51 Pegasi b, a gaseous ball comparable with the solar system's biggest gas giant, Jupiter. This discovery started a revolution in astronomy, and over 4,000 exoplanets have been found in the Milky Way. Strange new worlds are still being discovered, with an incredible wealth of sizes, forms, and orbits. They challenge our preconceived ideas about planetary systems and are forcing scientists to revise their theories of the physical processes behind the origins of planets. With numerous projects planned to start searching for exoplanets, we may eventually find an answer to the external question, or to the eternal question of whether other life is out there. This year's laureates have transformed our ideas about the cosmos, while James Peebles' theoretical discoveries contribute to our understanding of how the universe evolved after the Big Bang. Michael Mayer and Dieter Kalos explored our cosmic neighborhoods on the hunt for unknown planets. Their discoveries have forever changed our conceptions of the world. A little bit. Changed the conceptions a little bit. Here's some problems that I want to share with you guys. The universe being 14 billion years old? No way, man. If you measure the DH ratios of Mars, I have here in a paper, it's a one-page paper actually, the DH ratios of Mars makes it about 4.74 to 6.81 times older than Earth, because the DH ratios are that much higher. It follows from the DH ratios. So if the Earth is 4.5 billion years old, then Mars is 21.33 to 30.65 billion years old. If the Earth is 10 billion years old, then Mars is 47.4 to 68.1 billion years old. So any way you slice it, Mars is at least 21 billion years old. And if you look at it, it's pretty obvious. Yes, that thing is old. Very old. Very, very old. All the oceans are gone. The atmosphere is almost completely dissipated. The magnetic field is almost completely disintegrated. There's no magnetic field. It's a barren wasteland. It's extremely old. At least 5 times older than the Earth. That's obvious. So to say the universe is 14 billion when you have Mars in it, come on, man. But that isn't even the kicker, though. The kicker is that we have the DH ratios of Venus, and I have Venus's DH ratios as being, well, this is due to measurements. I didn't even measure this. Its DH ratios 1 deuterium per 62 and a half hydrogens, or 1 deuterium for every 40 hydrogens, meaning there's a hell of a lot of deuterium that's been building up. Why is there so much deuterium? Well, it's because the thing is old as shit. It's far, far older than Mars. I have Venus at least between 100 and 156 times as old as the Earth. I seriously believe that Venus is at least 450 billion years old. This is no joke, people. We're looking at objects that are far beyond our imagination and age. So what's happened here is not only did we move past the young Earth creationism of 6,000 years old, everything being 6,000 years old, created in 7 days or whatnot of the textbooks of yesteryear or whatnot. They actually taught that the Earth was 6,000 years old back in major universities like Oxford back in like the 1700s and whatnot. True story. They actually taught that stuff. We moved past that. James Hutton brought us to uniformitarianism, which means the Earth was extremely, extremely old, and he proved it by going to Sycamore Point and showing how the rocks were intermingling at Sycamore Point. So we went from 6,000 years old to 4.5 billion years old because we started to radiometrically date the rock formations on the Earth. And then now what's happening again is it's expanding past the previous creation mythology that was created back in the 20th century, which is Big Bang creationism. We're moving well past that too. That was 14 billion. Now we realize that Mars is at least 21 billion years old and Venus is at least 450 billion years old. So the Big Bang creationist thing it disintegrates. I'm not too sure if astronomers actually still believe it. I guess, awarding the Nobel Prize to these researchers is kind of like, retirement money. Here you go. Here's your retirement money. Now move along. Let the fresh young blood figure this stuff out. Now clearly that was the wrong path to take. So, I mean, it hurts to say that, but I think it's what it is. It's like retirement money. It's like, here you go. Here's your retirement money. Let the young minds come in and fix all the stuff that came before you that you haven't been able to fix. But anyways, there's that. And the second half of the Nobel Prize, in October 1995, Michael and Thaddeus announced the first discovery of a planet outside of our solar system, an exoplanet. And sure, maybe that would be correct. But in this theory, stellar evolution is planet formation, meaning cavemen made the first discovery of an exoplanet. The first time any human being, or even pre-human being like Homo habilis, looked up at the night sky and saw those little dots in the night sky, those are young, hot exoplanets. They're not stars. They're not a mutually exclusive thing here. So the discovery of the first exoplanet actually goes to people who we don't even know who they are. People who probably didn't even speak English, people who probably didn't even have written language, people who were just still struggling to survive by hunting and gathering and sharpening stones on other stones so they could, have tools to work with. Those were the first discoverers of what's up there, because they're the ones the first to see it the first time. And that's what really sets the lower end of our understanding of nature. It isn't, how can I say this? It isn't that we discover more things. It's what's happening is we're discovering that we've already known what we're looking at. What we're doing now is reinterpreting what we have always observed to be there. And that's the big difference. That's why this theory is so powerful, is because I don't necessarily need more information, more data, more experiments. I already have everything I need to develop this theory. What I have now is an alternative understanding. I can see these objects for what they actually are, and I'm interpreting it in a different light, using what we already understand about them: their masses, how bright they are, how much energy they spin with, their axial angular momentums, their chemical compositions, the levels of differentiation they have. I already have all the information available. I don't need to go out and get more information. What I have now, and what I hope my listeners have now, is an alternative understanding of what it is we're actually looking at, so they can interpret the pre-existing information that we've gathered over many years in a light that actually makes sense. But, the Nobel Prize Committee and, all this, the big prizes and the big awards, it's sort of like, I don't know, it's like, okay, yes, they did a lot of work. They're really important work, but the truth about it is that's only one level, okay? We have multiple levels. And sure, they did all that work in the past, but it's not that they're the top. They're not the top anymore. There are still more levels to go. And there are people that can look down on them and say, hey, well, this is what it actually is. It's not being arrogant or haughty or whatever. It's just a higher level of understanding, and it's that simple. Basically, all right, you guys, made this video long enough. Later.